A model train travels on a straight track such that its acceleration after t seconds is given by a of t is pt take away 13 centimeters per second squared. This applies for t between 0 and 10, and p is a constant. Determine the initial acceleration of the model train. So we're just after a of 0, and that's going to just be negative 13 centimeters per second squared. The model train has an initial velocity of 5 centimeters per second. After 2 seconds it has a displacement of negative 50 centimeters. A further 4 seconds later its displacement is 178 centimeters. Determine the value of the constant p. Well, v is the integral of the acceleration. So that's going to be pt squared on 2 take away 13t plus a constant. But we're told this. So v of 0 is equal to 5. That's going to mean that c is equal to 5, since when t is 0, pt squared over 2 and 13t are both 0. So that tells me that v is going to be pt squared on 2 take away 13t plus 5. Now let's think about displacement. We're going to integrate again. pt cubed over 3 times 2, which is 6, take away 13t squared on 2 plus 5t plus another constant which we'll call k. Now after 2 seconds the displacement is negative 50. So x of 2 equals negative 50 is going to be, so if t is equal to 2, t cubed would be 8, 8p on 6, or if you like 4p on 3. And then 2 squared is 4, divided by 2 is 2, so that would be minus 26, plus 10 plus k. Rearranging, we get 4p on 3 plus k is equal to negative 50 plus 26, take away 10, is going to be negative 34. And I'm going to call that equation 1. After a further 4 seconds means t is equal to 6. And the distance there is 178. So x of 6 is equal to 178. That is going to be, so p times 6 cubed divided by 6 is 36p. 13 times 6 squared divided by 2, that's going to be 234. And then 5 times 6 is 30. And then we've got k. Rearranging that gives me 36p plus k is 382. Call that equation 2. And then just solve that on the CAS. And we will get that p is equal to 12, which is what we wanted. And k equals negative 50. So let's move to part C. When is the model train at rest? Well, we now have that v is equal to 6t squared minus 13t plus 5. We want v equals 0, and we can just solve for this on the class pad. We get t is equal to a half and 5 on 3, or if you like 0.5 and 1.6 recurring if you're working in decimals. How far has the model train travelled when its acceleration is 47? Well, we now know that a is equal to 12t take 13. So 47 is 12t take 13, gives us 60 is equal to 12t, t is equal to 5. So we're after the distance in the first 5 seconds, and we can do that by integrating between 0 and 5 the velocity, which is 6t squared minus 13t plus 5. So it has to be the modulus because we know it changes direction, but that will sort that out. And we get 115.68 centimeters.